Hello! Right, question 7a. Sketch the graph of any cubic function that has both three distinct real roots. Right, so that means it crosses the x-axis 3 times. Crosses through the x-axis 3 times, 3 distinct roots. Okay, if it had not distinct roots, it could have repeated roots. That's where they bounce up, boing, or they bounce down, boing. Okay, so we want 3 distinct roots. We want it to cross the x-axis 3 times. And it's got a positive coefficient of x cubed. So that means the number in front of your x cubed is greater than 0. So 1x cubed, 2x cubed, so on. Right, so we all know that a positive cubic is a wee shape. Hey, do you remember that from year 1? A wee shape. And a negative cubic is a shape. So it starts at the top and goes down. It's negative. Wee if it's positive. Okay, so we want a positive one, and we want it to have 3 distinct roots. So it's going to have to go wee through the x-axis here, here, here. And it doesn't matter where those roots are for this question. It says any cubic function. So you just need to show something that goes like that, like that. So that would have 3 distinct roots. It doesn't have to all be on one side, you know, like with our roots 2 this side, 1 this side. It doesn't matter. Okay, because for this question we're just sketching any old cubic function. Right, 7b, the function x, so we've got a positive cubic. P and Q are constants and P is greater than 0. That's going to be important, I would imagine. Okay, and show that there is a turning point where the curve crosses the y-axis. So straight away, a turning point is where dy by dx, or in this case f dash x, is equal to 0. Okay, at turning points. Do we need to write that down? Yes, we do. Okay, because that tells the examiner we know what we're doing. Where the curve crosses the y-axis. So when the curve crosses the y-axis, that tells us x equals 0 at that point. Okay, so let's go off and find f dash x then. So differentiate that, 3x squared plus 6px, and that q will go away. And we want the turning points, so we want where f dash x equals 0 at. So 0 is equal to that. And we can take a common factor out of both those terms of 3x, and that will give us x plus 2p. Okay, so therefore this is true when x equals 0, because either this bit on the outside can be equal to 0, or this bracket here can be equal to 0, so x equals minus 2p. Therefore, there is a root exists at x equals 0, therefore, where the curve crosses the x-axis. X-axis. The curve crosses, there is a turning point. Just in case it asks you to, you know, there may be an explanation mark here. I mean, this is a 3-mark question, so you're probably going to get 1 mark for differentiating that there, 1 mark for identifying these roots, and maybe 1 mark for your explanation, or putting that f dash x equals 0, something like that. So it's important that you include all these little explanations as you're going along. Right, so for the last bit, this is our, oops, I don't like the way this is over the page at all, because you lose half the question. Right. Okay. Now we are told that this function here has got 3 distinct real roots, so it's going to have to be that shape we were talking. That shape we were. Oh, come on. What's it doing? It's going to have to be. No, come back. Right. It's going to have to. Oh God! Why is it doing this to me? Don't do this to me. It's not letting my pen work. Come on. No. Is it that one? No. What's that? No, it's not that. Oh God, I'm so sorry. 1 minute. Okay, we're working now. Right, so it's got 3 distinct real roots and it's a positive cubic. This is a positive cubic here. So we know it's going to be, well actually let's just try drawing it down here. It's going to be that shape there. And it's got to have 3 distinct real roots. Right, so if this is our x-axis here, then this turning point here needs to be greater than 0. Your y coordinate or your f of x here is greater than 0. And down here at your other turning point, this is where your f of x is below your x-axis, so it's got to be less than 0. Okay, now we know, because we've just found out from the previous question, that there is a turning point at x equals 0. So we know there's an axis going through here. Okay, now we know that this one is not x equals 0. Well, how do we know that? So let's consider the turning points. So we know there's a turning point when x equals 0. Okay, so f of x when x equals 0 is equal to q. Okay, it's equal to q. Okay, now, could it be there? Okay, then our other turning point was when x is equal to 2p. So when x is equal to 2p, your f of x is equal to minus 2p all cubed plus 3p times minus 2p squared plus q. Okay, so that's minus 8p cubed plus 12p squared plus q. Okay, right, so we've got the coordinates 0, q for our turning points, and minus 2p minus 8p cubed plus 12, this is a mess, isn't it, plus 12p squared plus q. Right, now we are told in the first question that p is greater than 0. So if p is greater than 0, then minus 2p here, this here, minus 2p must be less than 0, because minus 2 tells something positive, will give us a negative one. So that's how we know that this turning point here is at minus 2p, and that this one here is at 0. Okay, so for us to have 3 distinct roots, our turning points need to look like that. One at minus 2p and one at 0. Okay, so in that case, this, when x is 0, f of x is q, so that point there is q. So q must be below this x-axis here, because if it wasn't, if q was above it or equal to 0 there, anything like this, you're not going to have 3 distinct roots. The only way to get 3 distinct roots is if it cuts through the x-axis there and then cuts through the x-axis again after. Okay, so it can't bounce up at 0. So in that case, this one here tells us that q must be less than 0. Okay, for us to have this turning point here. Right, what about this one? So that tells us that this coordinate up here must be positive. Again, it can't be equal to 0 because that won't provide us with 3 distinct roots. So this y coordinate here must be greater than 0. So minus 8p cubed plus 12p squared plus q must be greater than 0. Okay, so if we wiggle that about a bit, put things on the other side. Oh, look at this, what a terrible mess I'm making of that. So q has got to be greater than 8p cubed, minus 12p squared, and q has got to be less than 0. I suppose if we wanted to, we could factorise this. So we could take a 4p squared out, and that would leave us with 2p minus 3. Do we need to do that? No, I don't think we do. Right, okay, so we're asked to find the range of possible values of q. So for the range, q has got to be less than 0, and q has got to be greater than 4p squared times 2p minus 3, whatever p is. And that will be your final answer. just thinking on a little bit more, 4p squared, that's always going to be positive. 2p minus 3, so this is positive. We need this bit here to be negative, don't we? Because q has got to be less than 0. So q has got to be less than 0. So in that case, 2p has got to be less than 3 in order for that bit there to be 0. But it doesn't really ask us to give the conditions on p, only the conditions on q. So I think we could possibly leave it just at that there. Okay, I hope that helps.